Okay, so let's first define Riemann integration. So Riemann integration was motivated by the area under the curve policy, area under the curve. And how they defined? They did in a very interesting way. So they did geometrically first. So I hope all of you know this. I have discussed this before, but I will discuss in a different way now. So let's say this is A, this is B, and this is the area. So this is the first bar, this is the second bar. Very good. So next, what we did is that, so the idea was that they defined x1, x2, x3, x4 small points. I think xn minus 1 because n intervals are there. So they broke down into this domain into n intervals. Step number 1, broke down into n intervals. And they approximated it by, in fact, as I told, if you remember that I have taught you about, like I've written a post on this, that they are trying to approximate the infinite by breaking up into finite regions. Okay, so these xi's are not defined as of now. It's like anything. And what that is that they observe the height at this xi's, height of the points. They observe the height of the point at this xi's. Great. Then what? Not the height of this point, but rather they did a bit more generalized stuff. So between these points, I'm alternating so that you can understand. They took a number ck, any number. So it's c1 for the first interval. It's c2 for the second interval. A random number in between. c3, the height. A point. c4, and it goes on. And last is this cn minus 1. They took this height, and what they did is that they constructed, so they, for each xi, so let's call this A as x0 and B as xn. For this xi and xi1 के बीच, they took ci. Okay, so it will be x0 as for yeah, or you can say yeah, it will be c1. Okay, c0, c1, c2, c3, cn minus 1, yeah, because this is x0 and x1 ke beech. So c1, and the third is that they did, the third step was they constructed the rectangle with the height and the breadth of the ck height. Okay, it was not the end point, but the ck ka height. They keep on constructing this, so they get some, rectangle areas and dot dot dot. Finally here, so they constructed rectangles Ri with height f of ci, the height, and breadth the xi, or rather xi plus 1 minus xi, this length. So what can be a good approximation of the area? Ci is a point between xi and xi plus 1. Any point, it's not defined which point, any point. So we consider the rectangles, and they have thought that it's a pretty good understanding, but also there's a statutory warning that understand here the area is not positive area, it's called signed area, because if xi is negative, f is negative, the height negative, then the area will be negative. Okay, that's the idea. So they sort of define that integration of a to b fx dx, it's close to, I will define what it means close to. the summation of f of ck times xk minus 1 and k from going to 0. So k is going from 0 to 1 to n. This was sort of the equivalence. But understand here they didn't know what was, so the two issues are there. They need to know what is xi. They also need to know how to select the CIs. Otherwise, how can they compute? So this was the first principle definition. So they need to compute, right? We have a way of computation that this is the derivative by a limit. We have a definition of limit. This is how to calculate the limit. But here, the CAK and XKs are not known. So we have a proper algorithm to compute it. Otherwise, you cannot compute it, right? So this was an idea. This was the question. This was the question they were trying to understand. And what did they define? So they defined like this, that like what was the next step? Since you understood this, what was the next step? The next step, they thought that they defined something as a sequence. We will see a sequence. So they defined something as called lower sum and upper sum. So what is the lower sum? So observe, when you're selecting CIs, that was random, right? The CI was any point. So this was to address that CI was the thing, how to select the CIs. So they defined something like this, that they define lower sum as in the following way. So remember what we are doing. We have this interval x0, x1, and then I have just give a small difference so that you understand x1, x2, x2, x3, okay, and this so on till xn minus 1 xn, right? But this is b. So what we did, we took a height, right? So imagine the function is like this. Let's say here it's like this. Let's say here it's like this. Here it's like this, and then this. Like it's like continuous. All are continuous, and just showing it in separate pieces. Okay, here it's like many things can happen, right? So what they defined is that, so this can happen. So what they defined is, are two things. So they defined something called lower sum. So what was that? So it was to address the CK issue, like how to define the CK. So they defined that instead of taking any CK, so whatever values it's taking, whatever the heights are taking here, let's take the minimum of that. Let's take the infimum of that. Let's define small mi as infimum of all the possible heights. So that x belongs to xi to xi plus 1. All the possible mi, the minimum height. So here it was this, here it was this, here let's say it was this, here it was this, here it was this, here it is this, all the minimum mi's. And they define something called upper sum, where we took the maximum of all these regions. So in the diagram, it's this point, here 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 it's this point, okay? And then they define the sum as, initially it was what? Initially it was summation f of ck, right? So they replaced it as f of ck, that random part, they replaced it as a lower sum ke liye, they replaced it as mk times xk plus 1. So how do, yeah, xk, it's a mistake here, I guess. C0 is, yeah, xk. C0 is for, I think it will be ck minus 1. Remember this small stuff which are important. So it's mk minus 1 times xk minus 1. And similarly, if it's the maximum, we get summation from k from 0 to n minus 1, capital Mk times xk plus 1 minus xk. They define the upper sum and the lower sum. Okay, they define this. Then what? Then what will happen? So the next part was that, so defined it given that this delta, okay. Okay, so the next part was how to take charge of that in the difference, the xi, how to select the xi's. So they did it in a different way. So once they did it, observe, we can easily understand that since it's finite, okay, so let's call it u. Okay, let's call it un. Okay, for n divisions, let's call it un. And let's call it, so let's call this ln, and let's call it un. You can easily understand that this is same, this is positive, of course. But mk is greater than or equal to small mk because the supremum is greater than the infimum, which implies that the upper sum is always greater than or equal to lower sum, the finite case.